Okay, here we go with creating an equation from a table one more time, and just getting another look at this is definitely going to help, especially when we see them side by side. So we can see that this table is clearly increasing in value as the x values increase, and so do these. So they're both increasing, but how are they increasing is the important part. Is it by multiplication or is it by addition? Well, pay no attention to the decimals. Let's go to the whole numbers, the ones that are a little bit easier to work with. So 4 to 12, 12 to 36, 36 to 108, not the same gap if we're using addition. But if we're to think of this as multiplication, isn't it multiplying by 3 every time? So that would be an exponential model. So it's y equals a times b to the x power. So we've come up with the b value. We know how much we're multiplying by, but it's that a value that we're still having trouble coming up with. And again, just identify where this is at 0. 0, 4 gives us the y-intercept, and so therefore we can put a 4 right in there, and you've got your entire equation. Come on over here, you can do the same thing. There is your y-intercept, okay? That's not going to change. And how is this changing on the y-axis side, or the y-value side? Well, if you don't like the negative numbers, that's okay. It's going to change the same amount every time, and it's going up by 3, up by 3, up by 3, up by 3. So this one's your classic linear because we're adding every time, and this would give us an equation where the slope is positive 3 and the y-intercept is at 4. And there you have it. Let's take a look at another one where these values are decreasing, all right? They're going down as you look at the y values. So looking at the y values, 40 to 20 to 10 to 5, it's not the same decrease every time. So once again, we must be multiplying. Now, if you're thinking about dividing, that's okay, but think about how that division is really translated into multiplication. So if you're dividing by 2, you're really multiplying by, yes, a half, okay? So that would look like this. And over here, we can see the change as not multiplying or dividing, but just as subtraction. So you can see that it's getting smaller by a half. So negative 1/2 is coming off every single time, right? You're subtracting by 0.5. So again, these look like this, exponential, whoops, where I've got to find my y-intercept and search through the x values and find 0. There it is. So because of that, the a value is 10 and the b value is 1/2 because we're decreasing this by multiplying by a half. Come on over to the other side where we'll have y equals. Again, we want to put the slope in, so that's a negative 1/2 x. And then the y-intercept, find the 0, is also 10. Okay? So there you have an example of a decreasing exponential and a decreasing linear function.